but we will leave this call open for an extra half an hour to be able to talk and open up for further questions, because we had a limited amount of questions. Brian, so for those that don't know me, it's Andy Eastlake from the Low Carbon Vehicle Partnership. I'm just introducing a number of speakers, and Brian will be running the slides and speaking to some of the LowCVP activity. But welcome to the Low Emission Freight Seminar, covering the second half of the programme. For those that weren't here last week, we covered some technologies looking at the long haul and heavy duty area last week, and the slides and the webinar will be available via our website in the near future. And this today is focused more on the lighter duty and the urban and electrification agenda. So Brian, if we just want to flick back, just to highlight, if we flick back to the webinar etiquette, sorry Brian, just to for anyone who's not aware or not familiar with Teams, please raise your hand if you want to ask a question, and ideally we'll use the chat as much as possible so that we can get through as many as possible. Anyone who's on a mobile device, you may struggle with those controls. Feel free to email myself or Brian Robinson at LowCVP, and we'll try and capture things. We will also be taking feedback after the event as well. So we'll aim to keep people muted, and as we said, we'll switch off most of the videos, or when you can switch off video just to free it off, and we'll display all of the presentations via this medium. Just flicking through. So welcome. We're now up to about 60 odd people. So let's go to the next slide, Brian. The agenda, as I mentioned, aiming to wrap up the formal process around about 3 o'clock in 2 hours' time, but we will keep the webinar open, and happy to talk to people and try and answer questions for the half hour following that. So if we're rushing to get through that. The aim is to cover 4 of the projects within the LEFT programme. I'll give a little bit more background on the programme, but we'll cover 4 projects today. And within the middle of that, we aim to have a comfort break for those that need a 5-minute break. Roughly around 10 to 2 is the target for that. So first things first, probably is just a quick bit of background on why the Low Emission Freight Programme was put in place in the first place. Just to highlight, and we won't spend long on this, just to highlight that freight, and road freight in particular, is a key component of our greenhouse gas challenge here in the UK, and actually an increasing proportion of that. So this graph from the Transport Decarbonisation Plan strategy document highlights the increase that the HGV and van sector has seen over the last 20 years. And the focus for the Low Emission Freight Trial is really on supporting the decarbonisation of that sector. As we mentioned, we've had a range of projects, and we'll touch on the broader programme, but the activity that we've been focused on has been focused on HGVs and vans, and we sort of grouped those together, even though they're dealt with separately in legislation and various other ways. And of course, underlying this as well is the focus on air quality and cleaning up our streets and our urban air quality. Let's move on. So I'll hand over to, well, no, actually, we'll cover this. So the LEFT programme itself, just a few acknowledgements. This was delivered through Innovate UK, and we have Innovate online with us. So if there's any questions for them. It was about 20 million programme over 3 years. And as we mentioned, emissions and air quality focus. And really, this was a demonstration to take the concepts and proven concepts, to operate them in the field and actually demonstrate them in use. Funding was all delivered by the Office for Low Emission Vehicles, and John Bray will be giving a slide on the OLEV strategy in a moment. All of the projects that carried out their on-road operations were monitored in service, both by the projects individually, and we'll hear from each of the projects today, and it was very important to get the projects to present their views of the technology and how that worked in operation. As well as the independent monitoring of that data on the road that TRL carried out on behalf of Innovate and OLEV. And then there was an additional phase of work that was additional to previous programs of this type that actually ran independent testing and analysis of the technologies around a consistent set of test cycles that LowCVP was very actively involved in. So we have in-service monitoring and independent emissions testing are the key bits of data that you'll see from Brian and TRL, and the projects themselves will obviously be showing what they got from operating the vehicles in the field. At that point, I think if I can hand over to John Bray just as an intro from OLEV. John?
Yeah, thanks very much, Andy. Afternoon, folks. If we just go to the next slide, please, Brian. So my name's John Bray, and I'm the R&D Program Manager at the Office for Low Emission Vehicles, OLEV, and I manage the R&D portfolio and strategy. Great to have so many of you tune into the second half of this left dissemination event, and I was just going to quickly talk a bit about OLEV, who we are, and what we do as we're the funder for left. So we're a joint departmental entity, reporting to ministers from both the BEIS and DFT side of the house. Our fundamental objective is to essentially drive the market for ultra-low and zero-emission vehicles, which are enabling through a substantial investment support package and publishing of national policies and legislative measures. On the strategy side, so a lot of you will be aware of this, but by 2050, we want almost every car and van in the UK to be zero emission. We want the technology needed to deliver that to be designed, developed and manufactured in the UK. So as part of this, we're consulting on bringing forward the end to the sale of petrol and diesel cars and vans from 2040 to 2035, or potentially earlier if a faster transition appears feasible. It's be the first time as well it would be including hybrids within that. The consultation for this ends this Friday, so 31st of July. Really suggestive, and if you have an interest in this area, which I'm sure you will, that you contribute to that. So Friday, closed Friday, that closes. Just a bit on the investment side from the OLEV, we're providing nearly £2.5 billion to position the UK at the global forefront of ultra low and zero emission vehicle development, manufacture and use. Pleased to say this is one of the most comprehensive support packages in the world and of its kind. So we're pleased with the offer that we're providing. I guess just really quickly for a bit of context, grants included within that investment include through our consumer incentive package, so our plug-in car, van, taxi and motorcycle grants. Just a bit of context that on the plug-in car grant, we've provided or supported over 230,000 vehicles to date, which really demonstrates the encouraging uptake of EVs to date. On the infrastructure grant scheme side, we offer support through the on-street residential charging scheme, EV home charging scheme, and workplace charging scheme. I guess more recently, at Budget 2020, the Chancellor announced a further 500 million for the rollout of rapid charge points and charging hubs, which essentially means that EV drivers won't be more than 25 miles from a given charge point. So working hard against that commitment. I can see a few questions coming through already. We've also delivered a lot of consultations aside from the main 2040 one, which includes smart charging, building regulations, and improving the consumer experience. We also work very closely with local authorities in the local delivery space. Support includes provision of a definition for what an ultra low emission vehicle actually is, or what ultra low emission truck is, a ULET definition, which LowCVP, Andy and Co have helped helping us to deliver. We've also provided over 40 million for the Gold Ultra Low City Scheme, which provided funding for 8 exemplar cities to sort of pave the way with EV infrastructure rollout. This included Dundee, Milton Keynes, Bristol, etc. Just on the R&D side, so my side, since 2010, as Andy was alluding to, through Innovate UK, we've helped provide hundreds of millions of pounds in grants to support a range of ultra low and zero emission technologies. These are delivered through a range of competitions and initiatives, which includes our IDP program, which is our integrated delivery program, which tends to have a different focus for each call. So it might be power electronics, machines and drives, freight, or light weighting. The niche vehicle network, the NVN, as you can see there, that's another platform that we administer funding through, but sort of focus mid-TRL, again, as the name suggests, in the niche auto sector. Yeah, obviously we've supported against sort of fleet trials through the LEFT program, but also innovation in the charging and wireless, the infrastructure space, so on-street charging and wireless charging space, again delivered through Innovate. Just in terms of the freight, on the freight side a bit more, we're supporting freight decarbonisation from a policy point of view through the TDP, so the Transport Decarbonisation Plan, which sort of includes targeted R&D investment by identifying the best technological alternatives to enable that net zero overarching kind of milestone. The regulatory framework for this is currently underpinned by EU derived regulation, which sets fuel efficiency targets for vans and HGVs. So the targets for this are sort of 15% improvement by the mid-2020s and 30% improvement by 2030. I better stop there. We've got a lot to get through, but hopefully that gives you kind of a flavour of what OLEV does and how sort of freight fits into that space. So yeah, I'll hand back to Andy and enjoy the rest of the session. Thanks, folks.
Thank you very much, John. What I can reiterate on John's behalf is that government are absolutely in listening mode and are looking at ambitious policies at the moment. So the consultation on car and van phase out of ICE is open now, and the Transport Decarbonisation Plan, actually this data that's been developed through these projects will feed into that as part of it. Just very, very briefly to sort of set the scene, the freight program, the Low Emission Freght Trial, covered all freight operations from light van all the way up to heavy duty truck. We focused last week on some of the heavy duty truck areas, and for those that don't know, within freight, about 75% of the fuel used is in the heavy long haul and regional operation. So a lot of the focus with that was in decarbonised fuels and the opportunity from biomethane or indeed hydrogen as a combustion fuel. So decarbonising the fuel can really drive down that carbon content in those long heavy. But obviously the zero emissions operation in city centres potentially involves different technologies and different or a combination of technologies. So today we're focusing on some of the technologies that are more likely to deliver within the lighter weight and the more transient operation, the city centre and urban operation. We'll come back to this slide towards the end, but we've ended up evolving a series of sort of categories for the technologies that we've seen here. Evolution, ones that can be implemented very quickly and arguably shouldn't really need grants and support because they should pay for themselves. And today we'll hear about the kinetic energy recovery system trailer, which I think is a good articulation of that. We've then got some transition technologies we regard as things like alternative fuels and some of the range extended activity. So we'll hear from Teva on the range extended heavy goods vehicle program. And then what we've tasked revolution technologies that make that very significant step change, up to 80% well-to-wheel reductions from depending on the source of the fuel and things like that. And particularly the battery electric vans and HGVs sit in that category. So without further ado, I think we should jump straight into the first project, which is a great exemplar of the Gnewt Menzies all-electric van operation in London, and I'm very pleased that Philippa Ellis from the GLA and Adam Smith from Menzies are available. Philippa, Adam, I'll hand over to you.
Thanks, Andy. I'm Philippa Ellis. I work in the Environment Unit of the Greater London Authority, and I'm going to start talking about the project, and then Adam's going to come in at the end to talk about the benefits to Menzies. So just to outline the aim of the trial, basically what we were doing was comparing larger vans, that's between 7.5 and 13 metre cube capacity, commercial delivery electric vehicles, comparing them to diesels, equivalent diesels, against a number of factors, mainly environmental and economic. And we also compared the modified larger vans to existing smaller electric vans that Gnewt were already operating. The partners involved, the lead partner was Gnewt, which is owned by Menzies Distribution. We were a partner in the project, mainly leading on the communication side and managing the subcontract with Arup, who provided us with the data analysis and reporting. And in terms of the vehicles themselves, there were 26 trial vehicles, all battery electric, and there were 3 types of modified electric van. The majority of these were converted by a company called Voltia. They were converted by from Nissan ENV200 electric vans, just to make their chassis bigger so that there's more capacity for parcels. The middle van shown was converted by a company called BD Auto, and that was converted from Educatu van. So that wasn't made bigger, but the battery dynamics were changed for that van. And then on the right, there was the another Nissan ENV200 converted by a company called Vic Young, based in Newcastle. Again, just to make the capacity bigger. So in terms of the operational characteristics, I won't go through all of these in detail. You'll have the slides afterwards, but just to mention, the vans were operating in central London, so you can imagine very low speed, lots of stop-start operation, doing quite a low mileage a day. The depot of Gnewt is based in Bromley by Bow, so they're only doing on average about between 35 and 39 kilometres a day. Payload volumes of between 7.5. So in terms of the in-service data, it was collected using a telematics system, Fleet Karma, the company. And the sort of data collected was energy usage, efficiency, distance travelled and greenhouse gas emissions. Data was collected between November 2017 and end of September 2019. And so we looked at the data and compared them to diesels in terms of the tailpipe, CO2 emissions, and other air pollutants, energy usage, and so on. We found some issues with Fleet Karma data. There was some missing data for some short journeys, and also there was some concern of the accuracy over the baseline diesel data. So LowCVP carried out some independent testing to provide us with more accurate results. And just to mention also that the weekly distance and capacity was lower with the diesel NV200 compared to the trial ENV200. Next slide, please. So these are just a few of the results. More of our results are found on our trial website. But in terms of fuel or energy consumption comparisons, the trial vehicles used significantly less energy, much more energy efficient than the diesel equivalents, and that was found with the BD Auto as well. And we've listed the tailpipe emissions and pollutants savings as well over the trial period for all the vans, for the 26 vans, almost 78 tons CO2. And as I said, all the reports and full results are available on our website via the link. Next slide, please.
Okay, thanks, Philip. It's Brian Robinson here. I'm just going to take over for the next few slides and go through the results of the emissions, the independent emissions testing for each of the technologies, and then I'll hand back to Philippa and Adam to wrap this particular project up. So the testing were done at Millbrook, was on the Voltia extended battery electric van compared to a bog standard Euro 6 diesel equivalent vehicle, same payload, same size. Testing was originally on the dyno, so an indoor rolling road at Millbrook. very highly controllable, repeatable. Unfortunately, we found one of the hazards with testing electric vehicles that happens occasionally, but not uniformly, was that the regen braking system didn't work properly on the dyno. So hence we moved to testing the electric vehicles on the track, but still the diesel vehicles on the dyno. The test track tests though were done to exactly the same cycle, so the dyno cycle rather than our standard test cycles, and that cycle covers all this range of operations, right from very congested city centre type operation up to motorway running at 70 miles an hour. Okay, so in terms of the fuel energy, very much in line with what Philip has just reported from the in-service trials. These are the litres per 100 kilometres fuel consumption of the diesel vehicle on the different parts of the cycle. For those of you watching in black and white, these are something like 35 to 45 mpg. I've put them in litres per 100 kilometres here, and this converts that number into kilowatt hours per kilometre. I know Philip had just showed megajoules per 100 kilometres, but there's a factor of 3.6 in there somewhere. You should get the same numbers, or roughly the same numbers. So these were at 60% payload, and these are also allowing for the charging efficiency, which was measured at Millbrook, but found to be quite low. That's a bit lower than we'd normally find. That's more likely to be a reflection of the particular charger used. So charging efficiency can vary depending on whether it's AC or DC, what the temperature is, etc. So that's very much a worst case. I would suggest we usually expect the efficiency to be a bit higher than that. But even using that efficiency as measured, we're getting up to 80% overall energy savings in the city centre, and of course the energy savings for the electric go up as speed comes down. So as the diesel vehicle gets kind of less efficient, down to at worst 7.8 litres per 100 kilometres, the electric vehicle with its regen braking gets more and more efficient, and that just summarises what I've just said there. So in terms of greenhouse gas emissions, clearly out of the tailpipe, this is a full electric vehicle, so there is no tailpipe, there are no tailpipe emissions, unlike the diesel, where this is the sort of CO2 equivalent emissions from the diesel vehicle. But converting the electricity use into greenhouse gas emissions, i.e. in the production of the electricity, using, these are standard DEFRA factors, these are 2019 factors. The keener amongst you will know that the 2020 figures have just been released last week, but we've been using the 2019 standard factors for grid average electricity, and this is what the emissions come out as compared to the same equivalent calculations for the diesel. So this is what's coming out the tailpipe. These higher numbers reflect the emissions associated with producing the diesel fuel and getting it to the petrol stations or the depots. And again, similar orders of magnitude, 50 to 80% type savings, getting bigger, of course, in the lower speed city type operations. We have also, as Andy mentioned, where you get the fuel or energy from is a very live issue amongst many of these fleet trials. So we have also done some parallel calculations. If you didn't use the standard factors from DEFRA's greenhouse gas reporting guidelines, you instead adopted a well, actually my electricity is on a fully 100% renewable tariff, so there's only a small, much smaller proportion of emissions associated with the transmission and distribution system, for example. Then these savings would increase to, getting on for 100%, of course, 90% plus with renewable electricity. Obviously, the pollutant emissions are quite easy to deal with. For the battery electric van, there is no tailpipe, so there is no pollutant emissions emanating from the tailpipe. At least, of course, there are still potentially some brake and tyre wear, but that's a much more complex and wider issue, not covered in these trials. But just for comparison, these are the Euro 6 diesel van NOx emissions to compare against. Don't have the particular number emissions from the diesel NOx broken down by cycle. We have them for the whole cycle, but not for the individual parts, so they're not shown here. And back to Philip, I think, for the last couple of slides.
Okay, thanks, Brian. This has got a lot of information on it, this slide, so probably best read at your own your own time. But yeah, the headline figure was that the larger trial vehicles obviously delivered more parcels. They had more capacity, so it was estimated on average 30% more parcels a week. We did driver surveys and very high satisfaction with all the vans, the highest being the BD Auto, followed by the Voltia. Smart charging was used. All the chargers were installed by EO charging, and obviously reduced the peak load and avoided a grid upgrade. And in terms of economic comparison, we found that the charging costs for the EVs were 75% less than if you'd fueled the vehicles with diesel, and the total operating costs on average about the same. The barriers, the main ones we found were availability of larger vans and the higher capital costs. There is a barriers report within the website as well to read in more detail about all the barriers, and it includes some solutions as well for these barriers. In terms of the left trial, it's really helped us to kind of promote the benefits of electric vans and using real world testing, and to kind of reduce those perceptions around range anxiety, higher costs, issues around charging. So yeah, in terms of the vehicles themselves, we found that they were going out with full charge and coming back with on average about 62% charge remaining, so they still had capacity even though they'd done a full round delivering parcels and coming back to the depot. And next slide. So in terms of learnings for future similar trials, all I really want to say is here that the baseline data, so we had an issue with around the fleet karma data, so we needed that to be sort of verified much earlier on in the trial. That wasn't highlighted until quite late on, causing some delays. So I just want to hand over to Adam Smith now, who's the Group Commercial Director for Menzies, to talk about the benefits of the trial to Gnewt and Menzies distribution.
Thank you, Philippa. Yeah, can you hear me?
Yep.
Yeah.
Hi, thanks, Philippa. Hi, guys. Just to sort of top and tail, I think effectively what I wanted to say is, there are obviously PR benefits and reputational benefits from running an electric vehicle fleet. We've done a number of things to kind of integrate electric vehicle distribution and use of electric vehicles into our long-term strategic plans. And through the process of the trial, we did a number of things. We won some major accounts, and we won a number of awards in terms of driving that through. So obviously that has knock-on benefits and implications for us as a business moving forward, not from a reputational perspective, but also from an economic and perspective, notwithstanding the benefits of driving the cost down and efficiencies on electric vehicles. I think in terms of one of the operational benefits, we did see some density of drops and efficiencies delivery going up, which is great. The drivers love the vehicles. I think Philippa's already picked up on that. So there was always a plethora of drivers wishing to drive the vehicles rather than the diesel vehicles. So that was good from our perspective. We, off the back of this trial and obviously off the back of the new operation, we are now extending our reach for the vehicles across our network. We've purchased more vehicles, and those will be introduced across the UK, not just in urban dense areas, but we're also running them in sort of fairly rural areas up in the Highlands and Islands of Scotland, where it makes sense as part of that, a part of our distribution plan and strategy. I think as the electric vehicles become more prevalent in terms of their payload capacity and ability to take sort of heavier freight, then obviously we will then start to drive that more into our network going forward. Talked about driver morale, and I think also some of the other projects that we ran in conjunction with this program were a portering program, which was in conjunction with Ford, where we would look to do final mile delivery on foot, but use electric vehicles to actually as a pickup and collection point for the porters that would run in terms of very high dense, low volume final mile delivery on foot. And we've been doing, you've got 60 charging points in our Bow depot, and we've been running the vehicle to grid charging process through that as well. So all in all, a very positive impact to our business running, not just being part of this great trial, but also in terms of building a proposition and a future that sees electric vehicles at the heart of what we do as a distribution partner to customers in the future. Thank you.
Great, thanks, Adam.
Brilliant. Thank you very much indeed, Philippa and Adam. We will take a couple of minutes in case there are any questions. If anyone wants to raise their hand, I've got Dominic Schofield with a raised hand. Dominic?
Hi, yes. Just a quick question, which Andy, you and Brian will recognise from the discussions around the phase out of ICEs. I noticed that you're coming back with, on average, 62% charge left, and also the cost of the vehicles is one of your barriers. A lot of the new electric vans coming into the market are being offered with 2 different battery sizes. Do you think it would be advantageous if would you be interested in buying these vans with smaller batteries if that meant that they were cheaper?
I think the answer is yes. And I think the thing is, one of the things that we have to do as a logistics provider and a distributor is we have to weigh up the density of the volume that we have in our network with the requirements for stem mileage, i.e. the distance they travel. And I think, as we grow, if there are definitely opportunities to do more short run sites and if that means we can do that on a cheaper vehicle, then yes, absolutely we do that. So if we are running inefficiently, for example, and not utilizing the full extent of the battery, and that's a high cost to us, then of course, yes, we'd look at doing that in a different way with a lower cost solution with a battery that perhaps doesn't have quite the same stem mileage capability, but might not be required. Certainly in very dense urban areas like London.
Thanks, Adam. Any other questions very briefly before we move on to the next project? I've got no other hands up. We're trying to handle what we can through the chat, so please feel free to raise them on the chat, or indeed raise any questions via email, and we'll carry on. The other thing I will flag up, Ian, chip in, yeah, Ian Waller.
Yeah, Andy, so it's just this comment that we do need to be really careful about when we're using grid averages. We need to be absolutely clear that if we use grid average, then we're going to get one number. But if what's happening is in actual fact and in practice is vehicles are coming back to base and being charged at peak times, actually you're using marginal dispatchable power, and that today might be a coal-fired power station, so it might be a coal-fired car. So we need to get it absolutely right when we're informing, coming out from these trials with what messages we give.
I'll take that one. You're absolutely right, Ian. I also know for a fact that Sam Clark, when he was there, installed some cheap timers to move his charging to later in the night, for partly for that reason, but partly for cost and things. So there are easy ways of shifting the charging. The whole principle of smart charging is a really big and interesting issue, and one that we're grappling with. But the grid averages and the numbers we use for the well to tank factors, in fact for all fuel types, are a key area of work for the LowCVP. And throughout this programme, we've used standard Bayes greenhouse gas reporting factors, but there's a lot of discussion to go on beyond that. I'm going to move on. I'll take questions via the chat, but I will move on to the next.
And apologies to Philippa, I've got too many L's and not enough P's there, but we'll correct that in the final version. Right. Okay.
Thank you. So the next project that we want to get into is entitled the Howdens Project. But I think it's more than just Howdens. So Mark Settler from Imperial College, I'm very pleased, has agreed to step in and present some of the findings from this. So Mark, can I hand over to you?
Thanks, Andy. Good afternoon, everyone. So what we wanted to do with this project was quantify the fuel consumption and emissions reductions from a kinetic energy recovery system. this was to be fitted onto 20 trial vehicles in total, so 10 trailers that were going to be coupled as a 44-ton HGV, and 2 types of trailers within that, so an urban trailer and a tall boy trailer, and 10 18-ton rigid vehicles operated by Sainsbury's. So it was going to be an 18-month trial period for both of those vehicle types. The controlled fuel consumption and emissions testing, Brian will talk about. On top of that, we did vehicle energy and emissions modelling, and also noise measurements to quantify any change in noise from the vehicles. I'm not going to mention the vehicle energy and emissions modelling any further, but within that we were able to calculate, say, return on investment, total cost of ownership, those sorts of things, using simulation over different drive cycles. And then the noise measurements we did didn't show any significant benefit, and the rest of the presentation will focus on the fuel consumption aspects. So the project was led by Howdens. Howdens and Sainsbury's were the 2 operators within the project. Alternatech with the technology provider, and at Imperial College we provided the data analysis and project management. So the overview of what we trialled, unfortunately we were not as successful as that previous project that was just shown. 3 KERS trailers were trialled in the end. The rigid vehicles were converted with the KERS equipment, but there were some significant technical challenges associated with that, and in the end the technology did not, it was not appropriate for that application, and therefore we couldn't proceed with a trial of those rigid vehicles, unfortunately. What the kinetic energy recovery system does is it regenerates energy during braking. So rather than all of that energy being lost to the brakes as heat, it's converted into electricity using a motor generator and then stored in ultracapacitors. So the KERS system that we were using was comprised of ultracapacitors, an electric motor generator, a high voltage module which controls the power, and a ECU, so an engine control unit, which controls everything really. The thing about this is it's most suited to urban driving with a lot of stop-start. So if you're driving on the motorway, there's no benefit of KERS. The units that were pulling the trailers were DAF MX-11 tractor units, and they were operating on standard diesel fuel. So point 4, the operational characteristics, typical journey lengths for the vehicles, for the left vehicles as shown here, as well as the average speeds, loads, and they're shown also for the baseline vehicles, so the diesel comparison vehicles. So typical journey lengths for the KERS vehicles were lower than the baseline vehicles. Average speeds were similar. Loads were slightly higher, and that has, given the limited amount of data that we do have for the operational trial, it means that we can't be completely definitive about the results and comparison between the fuel consumption of the 2 types of vehicles from the operational trial. The technical difficulties that we did experience limited the amount of operational data that we could collect. The drive cycles that these vehicles were undertaking in operation were similar to what we would consider to be regional drive cycles, and there was actually limited city centre driving. And if we looked at the telematics data, in the operational trial, there was approximately 0.07 stops per kilometre, and this is a really low number compared to the number of stops per kilometre that are in the city centre drive cycle that was conducted at Millbrook, for instance. So within our operational trial, we didn't see that the vehicles were undergoing that urban city centre style of driving. Next slide, please. So the vehicle telematics was from Microlise. We needed to combine that with operator trip records, which were used to match tractors to trailers. Initially, we wanted to do this with microlyze and spent microlyze data being collected on tractors and trailers. But we found that there was a timing issue on the trailer telematics units, which meant that there was a sort of drifting of the time on the trailer, which meant you could never quite be sure where it was and at what time. So in the end we had to do that manually. The data that we recorded included distance traveled per trip, starting time, fuel consumption, trip duration, gross vehicle weight, average and maximum speed. And we aggregated the raw telematics at the trip level and provided that. The trial that we were able to do in the end, so we weren't able to complete what we had originally wanted to do, and in the end we collected data for the full trial period, but the period over which the vehicles were operating was the 1st of July to the 20th of September 2019. In terms of comparing the left and the diesel baseline data, we do have a very limited data set for the KERS vehicles. It's 28 trips over 13 days. There are some differences. So the daily distance was different. So the average trip distance was also shorter for the KERS vehicles. The transport work done was different as well because of that trip distance, but the average load for the left vehicles was slightly higher than it was for the baseline. Average speeds were similar, but what the differences mean and the limited data mean is that we can't make a reliable quantitative comparison in fuel consumption. And so that's unfortunately the outcome of the operational trial. But here are the numbers, and they are surprising and disappointing in the sense that the KERS vehicles, so what's listed here as left, ended up with a fuel consumption of 0.261 litres per kilometre compared to their diesel baselines of 0.224 litres per kilometre. So what we observed in the operational trial was that the KERS vehicles actually consumed more fuel than the diesel vehicles. Now, there is a cautionary point here about the fact that the KERS vehicles had higher loads. However, another contributor to this is the fact that the KERS system induces an additional resistive force on the drivetrain. So the motor is continually being turned around, and there is a resistive force also of an additional drive axle on the trailer, and those combine to reduce the efficiency during trunking operations. In terms of the second point, diesel fuel is used, so any well-to-wheel changes would be proportional to the changes in fuel consumption.
Okay, thanks, Mark. Yes, so as before, testing done, independent testing on 2 standard drive cycles, this time on the Millwall test track at 60% overall payload. This is comparing the vehicle with the trailer KERS system fitted and operational to exactly the same vehicle with the system switched off. We weren't able, though, for timing and technical reasons, to test on the long haul, which is, as Mark says, the cycle where you'd expect least benefit, indeed no benefit at all, from a KERS system, because there's hardly any braking, hardly any slowing down on that, what simulates basically a long distance motorway trunking operation. So in terms of fuel consumption, and this we are, as I say, getting a good back-to-back comparison at exactly the same payloads, exactly the same speeds, etc. And sure enough, as we might expect, we're seeing a small benefit in reduced fuel consumption in the regional and same sort of percentages in the urban, and a quite marked bigger apparent benefit in the city centre, where of course a regen braking system would be working hardest and delivering most benefit. reasonable pattern. You might have expected the long haul to be kind of zero anyway, but as Mark said, because of the frictional losses in the motor on the new drive axle on the trailer, maybe we might have seen a plus 1 or a plus 2% in that operation. Who knows? We didn't test it, but probably wouldn't have been zero. And that also, one of the lessons we've learned in terms of our obviously quite a lot of testing over the course of this program is that Millbrook's standard test procedures, or indeed the industry's standard test procedures, aren't necessarily best suited to all of these technologies, and we may need to look at that in future. For regen braking type technologies like this, driving style is of course particularly important, because it does matter how quickly you apply the brakes and how gently you brake. In fact, effectively, the gentler you brake, the better, the more of that energy you will manage to recuperate. This doesn't sit well with Millbrook's existing standard test process. So these figures should be thought of as very much a sort of, again, perhaps a worst case. And we did do some testing using a different driving style and did see bigger savings, but because it's not the standard way of doing the test, and therefore kind of breaks down our apples with apples, doing everything in the same kind of way philosophy. I haven't reported those in detail, but there's some evidence there that you might get bigger savings if your drivers are trained to make the best use of the system. Greenhouse gas emissions, that just, as Mark says, that just converts the fuel consumption into firstly tailpipe, and then using standard factors again for pump average diesel fuel into overall well-to-wheel factors, and of course the percentages are the same. And this, as we wouldn't have expected this technology to have a marked impact on air quality pollutant emissions. It's just a small few percent saving in fuel, perhaps. So you wouldn't expect air quality impacts. And sure enough, we see a mixed. So the colour scheme here, I should have explained. Green is always good in that the left vehicle is therefore better than the diesel. Orange, it wasn't quite as good. And grey it's so close as to be hardly any different, within 2% typically. These, although there's a good mix of greens, oranges and greys, actually these are all well within the normal expectations of a Euro 6 diesel truck trailer combination, and of course, because we're testing different different times of the day, or different days, usually same time of year, but within a few days of each other, perhaps ambient conditions aren't necessarily exactly the same in each case. So there's no consistent pattern here or anything to write home about, really. So overall, no impact on air quality pollutant emissions, I think is fair to conclude. And back to Mark for a moment.
Thanks, Brian. So the findings from this is that these vehicles must be deployed on inner city and city centre drive cycles to realise any benefit. They were easy to integrate into the fleet, and they required no difference in fuel infrastructure. There was some positive driver feedback, so mainly drivers didn't notice any significant difference. In terms of safety risk, this is one area that really needs to be addressed, and there were potential weak points in the KERS system, and relying on relatively cheap pieces of equipment. So those pieces of equipment could fail, and that could have caused a safety risk, and so this definitely needs to be addressed. Other considerations were that training was required for anyone who could come into contact with a vehicle, which included maintenance staff, first responders, and the fire brigade, and this is because of the energy storage and the ultracapacitors on the vehicles. In terms of other findings, I've mentioned the additional drag on the drivetrain, and this needs to be addressed. The components of the KERS system were specified to be appropriate for the 18-ton rigid application, but unfortunately, once they were fitted, they weren't suitable. Retrofitting the drive axle onto the trailer was more challenging. It required special parts to be sourced, and also drive axle tires to be fitted. In terms of barriers, unfortunately, the in-service trial results are inconclusive. So, you know, we do have a small benefit that we observe in the control testing, but the regional type of driving that we saw in the operational trial meant that we saw an increase in fuel consumption. So there are outstanding technical challenges. The fuel consumption benefits being lower than expected obviously provide a challenge for the total cost of ownership as well. But in terms of where we are, we have a much better understanding of the technology, and this is due to the LEF support. So the project would not have gone ahead without it. Lessons learned. In hindsight, the KERS technology was not mature enough. Vehicles with the KERS system were displayed at a previous low carbon vehicle show, but these were for a different vehicle size and manufacturer, and in the end, the technology had to be adapted to the vehicles in the trial, and it was not as successful as we'd all hoped. There was an over-reliance in our project on a small subcontractor, and that was a risk that we identified, but it turned out to be, it's one of those risks on the risk table that turns out to be you know, to occur. In hindsight, we were over-ambitious in the scale of the trial, given the maturity of the technology, and also some costs were significantly underestimated and were incurred by the operators. In terms of suggestions, how, you know, for our particular technology, which was not as mature as others, which were trialed, perhaps a phased approach to support novel technologies, including an initial small-scale proof followed by a larger scale trial, could be appropriate. Given the challenges that we experienced, we did require a couple of project change requests to go in, and that process was quite arduous, and you know, I completely understand why there were deadlines on when money needed to be spent, but in some cases that lack of flexibility meant that we weren't able to change as much as maybe we would have done. And then in terms of consistency in information, that refers to I think at the beginning when it wasn't quite clear whether the fuel consumption testing would be covered by the project costs or not. But overall, you know, extremely grateful for the funding and support from LEF, and you know, we've got some important findings and results from this project. It's unfortunate that the results were not as successful as we had all hoped.
That's great. Thank you very much indeed, Mark. I think a good example of two different levels of technology readiness that we've had there. You know, obviously stock vehicles available from an OEM, and then a technology that's been developed by an SME and being installed, and that's exactly what Innovate funding helps to sort out and helps to flush out. So any questions for Mark very briefly before we have a couple of minutes break? I think there was a question here, a couple of questions around the additional costs of the technology. I don't know whether you've got that data at all, Mark, and potentially the additional weight of the technology in this.
Yeah, so in terms of the additional costs, that's something that I can characterize as being extremely high for the trial vehicles, and prohibitive given the fuel savings that we saw, you know, within the control testing. So that would definitely need to come down in future iterations. In terms of the weight, it was a few hundred kilograms that were added to the trailer.
It's Brian here, and just to I didn't say at the time, but we did compensate for that. So when we were comparing the same vehicle with the technology switched off, it was also with some payload taken off as well to replicate the the standard trailer without the kit fitted.
So we did the best we could in that. Martin Flack, you've got your hand up. Martin, please chip in. Long time no hear. Good to hear you, Martin.
Yeah, good afternoon, everyone. I'm a bit baffled by this project in the sense that we all know the benefits of a KERS system. It's a form of hybridization, and that's fine. But clearly, a KERS system is going to work on a vehicle doing urban operation. Arctic semi-trailers are largely designed for doing long-distance motorway. So it seems it's a bit inconsistent putting a KERS system on a trailer for a vehicle which is largely going to run up and down the motorway. What was the rationale behind it?
Yeah, so the rationale was that many of the locations that Howdens were delivering to were in urban areas, and so there was a hope that there would be a benefit attached to the driving within those areas. The vehicles, the trailers that were fitted were urban trailers, and then secondly, we would have done more. We would have had more results relevant to urban operations had the Sainsbury's rigid vehicles been trialled. So yes, they were still coming from out of town distribution centres, but they would have been delivering primarily to city centre stores.
Apologies, Martin. That may be partly our fault. I think the photo we've used here is of as you say, a more long haul Howdens trailer. It's in there because it's got the Howdens logo on it. I don't think, though, Mark will correct me if I'm wrong, but I don't think that's the type of trailer that was modified for this program. It would have been a shorter, as a more manoeuvrable urban trailer, a sort of 32-ton gross weight type vehicle.
And it's a good point, Martin. That's one of the reasons that we tested across every technology as far as we could across every drive cycle to try and extract that good analysis across the different cycles, because some technologies, as we know, will work in urban and some will work in long haul. And if you were on the previous event, we actually looked at a lightweight and an aerodynamic trailer, and obviously, those offer effectiveness in different areas. I'll take one more question from Charlie Nissen. Charlie?
Yeah, actually, it's I'm from Howdens, so hi, Martin. I know Martin quite well. Just to reiterate what Mark was saying, our fleet do a real combination. And we have a lot of people talking about doing last mile on one type of truck and the trunking on another. It's not really practical for us. Overnights, our vehicles do a lot of long distance trunking, and on days they go into the urban operations. So that's the reason we trialled this KERS on that, along with balancing that off with the local distributions on the rigids. The rigids, as we know, didn't work out, but we wanted to cover a broad spectrum of what that KERS technology could do. So on night time doing trunking on our vehicles, daytime going into the depots, was there still a benefit? And obviously it's a good question, but that's the reason we used trailers. But they're 10.6 metre urban trailers, twin axle, designed for the smaller of our depots that we deliver to, absolutely urban, but not enough urban, obviously, to make an impact.
That's great. Thanks very much indeed, Charlie. I will call a halt there. We'll have a 5-minute break. So at 3 minutes past 2, for those of us that need a 5-minute comfort break, we'll restart at 3 minutes past 2 with the next project. So I'll try and stay on, and any questions we can try and answer via the chat, but we'll take 5 minutes now.
Okay, thanks all. And Richard, that's you in terms of next project.